Welcome to G-Fun Facts Online. Imagine this. You pull out your phone, hail a ride, and a few minutes later, a car pulls up to the curb. But as you approach, you notice something strange. There's no one in the driver's seat. This isn't a scene from a sci-fi movie. It's a reality today on the streets of San Francisco, Phoenix, Beijing, and Shanghai. The Robotaxi Revolution is here, and it's poised to fundamentally change how we move, how we live, and how our cities are designed. So how did we get from futuristic dreams to actual driverless cars navigating our most complex urban environments? The concept of a self-driving car has been around for a surprisingly long time. The first public vision was showcased at the 1939 World's Fair in General Motors' Futurama exhibit, which featured radio-controlled electric cars on automated highways. It was pure fantasy then. Throughout the mid-20th century, experiments continued, with some researchers even trying to guide cars with wires embedded in the road. But the real breakthrough came in the 1980s with the rise of powerful computer technology. Projects like Carnegie Mellon University's NavLab developed the first vision-guided vehicles. These were clunky, rudimentary machines by today's standards, but they laid the critical groundwork. The real catalyst, however, was the DARPA Grand Challenges in the 2000s. These were military-sponsored competitions that pushed research teams to their limits, challenging them to build vehicles that could navigate tough off-road and urban courses completely on their own. These events captured the imagination of companies like Google, and the modern race for autonomy began. So what is the magic that allows a robotaxi to see and navigate the world? It's not one single thing, but a sophisticated symphony of sensors and software. At the core is a suite of hardware that acts as the car's super senses, creating a 360-degree bubble of awareness. First, you have LiDAR, which stands for Light Detection and Ranging. This is a spinning sensor, often on the roof, that shoots out millions of laser pulses per second. By measuring how long it takes for that light to bounce back, the car creates an incredibly detailed, three-dimensional point cloud map of its surroundings. It can precisely measure the shape, size, and distance of every object, day or night. Next are the cameras. High-resolution cameras are the vehicle's eyes, providing rich, full-color visual information. They are essential for recognizing and classifying things like pedestrians, cyclists, traffic lights, and road signs. This is where advanced AI comes in, interpreting that visual data to understand what it's seeing. Then there's radar. Radar uses radio waves to detect objects and, crucially, their speed. It's a workhorse technology that excels in bad weather, like rain, fog, or snow, where cameras and even LiDAR might struggle. Finally, ultrasonic sensors use sound waves to detect objects at very close ranges, making them perfect for parking and low-speed maneuvering. All the data from this symphony of sensors floods into the car's brain, a powerful onboard computer running incredibly complex AI and machine learning algorithms. This brain has four key jobs. First is perception. It fuses all the sensor data together to build a single, accurate model of the world around it. Second is prediction. It uses machine learning to anticipate what other road users might do. Will that pedestrian step off the curb? Is that car about to change lanes without signaling? The AI has to make educated guesses based on millions of miles of driving data. Third is planning. Based on its perception and predictions, the AI charts a safe and efficient path to the destination, all while obeying traffic laws. And finally, control. The brain translates that planned path into precise commands for steering, acceleration, and braking. Now, within the industry, there's a fascinating and fiery debate: LiDAR versus a vision-only approach. Most companies, like Waymo and Cruise, believe in a multi-sensor approach, arguing that LiDAR provides a critical layer of redundancy and is unmatched for precise depth perception. But then you have Tesla, which has famously ditched LiDAR entirely. Elon Musk argues that since humans drive with just 2 eyes, a car should be able to as well, using a powerful system of cameras and a neural network brain. It's a fundamental philosophical and strategic split, and it's still unclear which approach will ultimately prove superior. It's also important to understand that self-driving isn't a simple on or off concept. The Society of Automotive Engineers, or SAE, has defined 6 levels of automation, from level 0, which is your standard car with no assistance, up to level 5, which is full automation anywhere, anytime, under any condition. Most of the robotaxi services operating today are considered level 4. This means they are fully autonomous, but only within a specific, pre-mapped geographical area called a geofence, and under certain conditions. The ultimate goal for everyone is level 5, but we're not there yet. This brings us to the key players in this high-stakes race. First is Waymo, which spun out of the original Google self-driving car project. They're widely seen as the pioneer and a leader in the field, with millions of miles of driving experience. Their Waymo One service offers fully driverless rides in cities like Phoenix and San Francisco. Next up is Cruise, a subsidiary of General Motors. They focused on the incredibly challenging streets of dense cities like San Francisco. While they've faced some recent setbacks and a temporary suspension after an accident, they have been a major force in the space. Then there's Tesla. Not one to follow the crowd, Tesla is taking a unique path with its full self-driving technology, which is currently in a beta phase. Instead of a dedicated fleet, they are leveraging their millions of customer vehicles to collect vast amounts of real-world driving data to train their vision-based system. Elon Musk's long-term vision is a shared autonomous vehicle network, a goal recently advanced with a limited robotaxi service launch in Austin. Another interesting player is Zoox, which was acquired by Amazon. Instead of retrofitting existing cars, Zoox designed its vehicle from the ground up to be a robotaxi. It looks like a futuristic carriage, with 2 bench seats facing each other and no steering wheel or pedals. They've already launched a public service in Las Vegas. Meanwhile, in China, the tech giant Baidu is a dominant force with its Apollo open-source platform. Their Apollo Go robotaxi service is operating in numerous Chinese cities and is expanding internationally. They've been a leader in deploying services with no safety driver behind the wheel at all. We also have companies like Pony.ai, another major Chinese contender, and Motional, a joint venture between Hyundai and Aptiv, which has partnered with Uber to offer autonomous rides in Las Vegas. But technology is only half the battle. The road to widespread adoption is littered with major roadblocks. The first is regulation. The legal framework for autonomous vehicles is a messy, evolving patchwork. In the United States, there's no single federal law. Instead, rules vary from state to state, creating a confusing landscape for companies trying to deploy their services. China has taken a more centralized approach to promote development, while the European Union is working to create a harmonized set of rules for the entire bloc. Then there's the massive legal question of liability. In a traditional car crash, you can usually assign fault to a driver. But if a driverless car causes an accident, who is responsible? Is it the vehicle manufacturer, the company that wrote the software, the fleet operator who maintains the car? Legal systems around the world are struggling to answer these questions. Perhaps the biggest hurdle of all is winning public trust. High-profile accidents, even if they are rare, generate scary headlines and fuel public skepticism. Surveys consistently show that a large portion of the population is still hesitant to ride in a driverless car. Building confidence will require a near-perfect safety record, transparency from the companies, and a whole lot of public education. If these challenges can be overcome, the ripple effect on our society and economy will be profound. The most immediate impact will be on jobs. The widespread adoption of autonomous taxis could displace millions of professional drivers. However, it will also create new jobs in fields like remote fleet management, data science, and vehicle maintenance. The very concept of car ownership is likely to change. Why bear the cost and hassle of owning a car, dealing with insurance, parking, and maintenance, when you can summon a cheap and convenient robotaxi at a moment's notice? This is the core of a model called transportation as a service, and it could lead to a sharp decline in personal car ownership, especially in cities. The market potential is staggering. Projected to be a multi-trillion-dollar industry, the societal changes could be even more significant. Proponents argue that autonomous vehicles could dramatically reduce traffic accidents, as the vast majority are caused by human error. This could save tens of thousands of lives each year. Robotaxis could also provide unprecedented mobility and independence for the elderly, people with disabilities, and others who cannot drive. And think about our cities. If fewer people own cars, vast amounts of urban land currently dedicated to parking lots and garages could be reclaimed. Imagine those spaces transformed into parks, affordable housing, or community centers. Coupled with the fact that most robotaxis are electric, this shift could also lead to cleaner air and a smaller carbon footprint for our cities. So where do we go from here? The Robotaxi Revolution is not a future tense event. It's happening now. However, widespread adoption is still a long way off. Expect a gradual rollout, with services expanding to more cities and covering larger geofenced areas over the next decade. The industry still needs to perfect the technology, navigate the complex regulatory maze, and most importantly, earn our trust. The journey from a fanciful exhibit at the 1939 World's Fair to a tangible reality has been long and filled with incredible innovation. The coming years will be crucial in determining how this transformative technology is woven into the fabric of our society. The robotaxi promises a future of safer, more efficient, and more accessible transportation for everyone, but only if we can successfully navigate the road ahead. Thanks for listening to Fun Facts Online.